Good evening, everyone.
Good evening.
Good evening, Sash.
Good evening. We'll begin shortly. I request everyone to please be on mute. If you have any query, please feel free to unmute and ask any query. But if you don't have any, please be on mute.
शशि इनफैक्ट क्वेरी नहीं है, एक रिक्वेस्ट है।
Mm-hmm. Yes.
कुछ एक्सरसाइज एंड कुछ प्रोबेबिलिटी एंड स्टैटिस्टिक्स पे
Yeah,
कुछ
sure,
लिटरेचर,
sure. We'll do that today.
कुछ अगर लिटरेचर शेयर कर देंगे देन इट विल हेल्प टू गो थ्रू दैट।
Yeah, sure. We'll try to solve some problems, and I'll also share, point you to some resources. I
प्लीज।
request everyone to please be on mute.
Good evening, sir.
Good evening. Shrava, can you please be on mute? Okay. So we'll quickly do the revision of second week. Like last week I was not able to cover many of the topics. So we'll just go through those topics and then solve some problems, and then we'll have some hands-on on Python. Like we'll try to solve all these problems relating to probability distributions in Python as well. So let me check. Yeah, so the recording is being done. Fine. So good evening, everyone. Those of you who are joining for the first time, I am Saish Jaiswal, a PhD student in the Department of Computer Science and Engineering at IIT Madras. So last week we were supposed to cover all these topics, that is introduction to probability, random variable and distribution. So yeah, we'll have a look at it, and then we'll move on to this week's topics, that are sampling and sampling distributions. uh, I'll kind of like touch upon sampling and the point estimate and confidence interval. We'll see the details in the next class because it will become too heavy for this class. So let me go back to week 2, where we'll see some questions on probability. I hope my screen is visible.
Yes,
यस।
sir.
Okay,
Yes.
great, thanks. Okay, so can anyone quickly tell what is probability?
A chance is known as probability, sir.
A more formal definition? Okay, let me just tell. It's a numerical measure of likelihood that an event occurs. So, what is an event? That brings us to the question, like, what is an event? First of all, what is an experiment? So, an experiment is something that produces outcome. For example, let me toss a coin. So, what are the outcomes of tossing a coin? Say it's an unbiased coin. It can either have heads or tails. So I am performing an experiment which is tossing a coin. It has two outcomes, heads and tails. So in the literature, like probability literature, these outcomes are called events. So for example, if I toss two coins, so what are the outcomes, possible outcomes for tossing two coins?
One fold.
No, the possible outcomes. What are the events?
Two heads,
Four,
two
sir.
tails.
Four.
Okay, H
Total
heads,
four.
H
Two
heads.
heads, two tails, one head and one tail. Tail, tail head, head tail.
Okay, fine. So these are the events that are occurring when you are doing the experiment of tossing two coins. I'm just rushing through it. Please, interrupt and let me know like if you have any queries. So we'll just do some like basic recap, and then we'll go on to some problems similar to what you get in your assignment. Okay, so an event is an outcome of the experiment that you are doing. It can be any experiment, like tossing a coin is an experiment, throwing a die is an experiment, taking a card from the card from the 52 available cards is an experiment, and so on. And after that, coming to elementary event, it is the event which cannot be broken down into further sub events. For example, tossing a coin, heads and tails. Now heads and tails cannot be broken down into any further events. Okay, so that elementary event is the event which cannot be broken down into further sub events. Then comes the question of sample space, method for describing sample space and all. So we'll see the questions. I think let us go to the questions, and through the questions we will try to revise these concepts. So let me go to the first question, and I request everyone to please think for some time. Even if you know answer, please hold on. I want everybody to think on the questions. Please don't put the answer in the chat right away. I'll ask you to have the answer, and then only put it in the chat. So the first question is, individual outcome of an experiment is called. Okay, let me just share the tab. Okay, please wait for the don't answer right away in the chat. I want everybody to think. Okay, so the an individual outcome of an experiment is called. Okay, you can answer.
Sample point B option.
Yes, so the answer is sample point. Okay, so now there is a confusion of some people are saying sample space. So sample space is nothing but a set of all the possible outcomes of an experiment. So for example, I am tossing a coin. The possible outcomes are, tossing a coin is an experiment. Possible outcomes are heads and tails. So this all set of all possible outcomes, heads and tails, is my sample space. All whatever possible outcomes are there. For example, tossing two coins, it is heads heads, head tails, tail heads and tail tails. So these are 4 outputs. So the sample space is HH, HT, TH and TT. Now every event in this, every outcome in this is a sample point. Okay, so I hope that is clear to everyone, this terminology. A sample point is one of the outcomes of an experiment.
Saish, in an exam, will the MCQs come?
Yeah,
Or
mostly MCQs. Mostly there will be MCQs. I'm not very sure about the theoretical aspect of it, but yeah, mostly there will be MCQs.
Okay.
Yeah. Okay. So second thing is, which of the following is not a method for describing a sample space? Okay, think over it. Think over it. Don't put the answer in chat. We'll discuss it. Okay, you can answer now. Please read the question carefully. Which of the following is not a method? It asks not. Okay, only 2 answers. What about the others? Yeah, please try to answer. We are not evaluating you, so you are free to answer even if it is wrong. Please do answer. I just want to know if people are getting the answer or not. Okay, fine. Let me just try to explain it on iPad. Okay, is my iPad screen visible to everyone?
Yes, sir.
Yes, sir.
Okay. So the question was, which of the following is not a method for describing a sample space? So first option was roster or listing. So in general you would have seen this. So tossing two coins, sample space is HH, HT, TH, TT. So this is known as listing method, where you are listing all the outcomes of an event. Now if the sample space is like 1, 2, 3, 4, 5, 6, rolling a die, this is listing, and you can say it in the set builder form, like write the same thing x such that x goes from 1 to 6. So this is listing or roster form, this is set builder form, and then there is something called as Venn diagram. So Venn diagram, in Venn diagram generally a rectangle represents a sample space, and in which we express or like draw circles representing individual events. For example, event A, event B. So say event A is having like a number less than 3, and event B having number greater than equal to 3. So it will be having like 1, 2 and 3 is at the intersection, then 4, 5, 6 and so on. So this is listing method, this is set builder, this is listing or roster form, this is set builder form, this is Venn diagram, and then there is one more representation called as tree diagram. So say if in the first, in tossing a coin, I toss two coins. So once I toss a coin, I have two outcomes, heads and tails. Now second time I toss a coin, I have two outcomes for this case, heads and tails. Similarly over here, heads, tails. So what are the outcomes? HH, HT, TH and TT. So this is known as the tree diagram. So here you can see in the form of tree. In computer science, a tree is a data structure, and in this case we are using tree to represent the outcomes of an event. Okay, so I hope this is clear to everyone. This is listing or roster form, this is set builder form, this is Venn diagram, and this is tree diagram. Now going back to the question, so let me stop the share over here. Okay, so question asks, which of the following is not a method for describing a sample space? So roster or listing, yes. Tree diagram, yes. Venn diagram, yes. But it says offset builder notation, but it's not called offset builder notation, it is known as set builder notation. So the answer is option C.
What is the difference between the set and the offset?
Offset, there doesn't exist any method like offset builder notation. It's just
There's no name.
yeah,
There's no name like this. Okay.
yeah. Set builder notation is the term used in probability theory. Okay. So I hope it is clear to everyone. Like please ask any query like if you have.
Sir, your screen is not visible.
Is my screen not visible to anyone?
No, it's clearly visible.
No, sir, it's visible.
Okay.
I think
Okay,
it's
thank you.
network.
Okay, I think it's network issue for the person who asked.
What is the difference between the event and then the other term which you
Okay,
use?
so event is actually like, for example, getting two coins. Getting two heads, it's an event, or getting at least one head, it's an event. So I'm tossing 2 coins. The possible outcomes are heads heads, head tails, tail heads and tail tails. Now the event is getting at least one head. So getting at least one head is heads heads or head tails or tail heads. So this is an event.
Okay, any one of 4 is not the event.
Sorry.
Any one of 4 is not the event.
If you define it like that, so getting exactly 2 heads, that is an event. So that is also one event, like
Okay.
HH. Getting exactly one tails followed by heads, that is an event. So individual element can also be like taken as an event if you define that way. Okay. Yeah. So coming to this question, a graphical method of representing the sample points of an experiment is, okay, let me just share the tab again. Please wait for the answers. Don't put that in chat yet.
Have you stopped sharing, Saish?
Yeah. Please sharing. Okay, think for, I'm giving you 30 seconds, just think over it. A graphical method of representing the sample points of an experiment is, okay, you can answer now. Okay. Fine. So we just discussed this, a tree diagram. So a tree diagram is a tree representation in which every node, it represents the outcome at of a particular experiment till that point. So as we discussed for the tossing 2 coins case, we were having heads and tails, and then for each of this outcome we were having another experiment like of tossing another coin. For each of like for heads we were having heads tails, and for tails we were having tails and heads. Okay. Next question, 2 events having non-zero probabilities. Okay, now this is something which you need to think on. Let me start a poll, that is better option. So just think over it. I'll just start a poll and then you answer via the poll. 2 events having non-zero probabilities can be mutually exclusive and independent, cannot be both mutually exclusive and independent, are always mutually exclusive, are always independent. Okay, I have launched the poll. Please try to answer and then we'll discuss.
Can we
Please,
both mutually exclude?
Rohini, answer via poll. If you are not able to find the poll, it is in the activity section. So you might be seeing like 3 shapes over there: triangle, square, circle. So in that there is a poll option. Okay, only 5 people have answered. Please try to answer. Okay, fine. So let us discuss this. Is my iPad screen visible? Okay, let me share it again. Okay, so the question was 2 events having non-zero probability. Okay, for that we'll have to discuss certain things. First of all, let us see few basic concepts in probability, that are union, intersection, and independence of two events, and law of multiplication, of course, before that. So let's say I have a sample space and there are two events, A and B. So in terms of numbers, say sample space is rolling a die, so possible outcomes are 1, 2, 3, 4, 5, 6, and say event A is 1, 2, 3, 4, and event B is 3, 4, 5, 6. Now, what is A union B?
One, two, three, four,
Sir, 1, 2, 3, 4, 5,
five,
6.
Yeah.
6.
So A union B is nothing but union of the two sets. But one thing you should be noticing over here, we are not repeating anything in the union. So every element in this set occurs only once. So that you need to take care. In set, every element occurs only once. In Python, there is something called as multi-sets, in which like multiple elements can occur, like element can occur multiple times. But this is for set in general that you have to take care about. Now, what is A intersection B? Sorry, what is A intersection B? Union is like addition.
3, 4.
Okay. So intersection is nothing but the common things between the two events, and union is like all the things for in B, A, and all the things in B. So in terms of this Venn diagram, this is A event and this is B event. So this entire thing will be called as A union B, and this intersection will be when A and B are occurring. So what is the common thing between A and B? This is A intersection B. Now, what is the complement of A? A complement. It is also written as AC or A bar.
Five, six.
Yes.
6.
Yeah. So A complement is 5, 6. So whatever is there in A, you will have to remove that from the sample space to get the complement of A. Okay. Now there is another, let me see what other things are there I am missing. Union, intersection. Okay. So now what is a mutually exclusive event? How do you define a mutually exclusive event?
The event that does not depend on another event is mutually exclusive.
No, that is the
Sir,
dependence.
if A intersection B is null set, then it may be mutually
Yeah,
exclusive.
yeah. So that is the definition. If A intersection B is null, so this is the way you can define null set or represent null set, either this way with no element or phi. Phi is the Greek character. So A intersection B, if this is null, then we can say that A and B are mutually exclusive events. So there is no commonality between the two events, A and B. So A is having certain elements, B is having certain elements. In list notation, say A is 1, 2, 3 and B is 4, 5, 6.
Hmm. So basically, A does not depends on B.
Dependency we'll discuss, Saurabh. Like there is a notion attached to it, like on dependency. So mutually
In case, sir, if we talk in terms of probability, then we can say we are using a coin to toss. It will have only two events, head or tail, and it will have 1, 2, 3, 4, 5, 6. So they can be said as mutually exclusive or not.
the events are mutually exclusive, yes, but it depends on the sample space as well. So your experiment, you are doing two different experiments over here. right?
Okay.
Yeah. So in within an experiment, I am having two events. Uh, for an experiment, I am having a sample space, and for that same experiment, I am having two events. Sorry. So we are seeing the mutual exclusion of the two events for a given experiment. This is within the realm of an experiment.
Within a single experiment, right?
Yeah, yeah. We are talking about single experiment, not
So we
multiple.
can say 1, 3, and 5 are odd numbers, and 2, 4, 6 are even numbers
Yes. So these
in
are,
a single
yeah.
event.
So these are two
If we are using
events.
a
Yeah. So these are two events, 1, 3, 4, 5, and 2, 4, 6. So if you take intersection of it, it is 0 or null set. Now let me talk.
commonality is 0.
Yeah, commonality is 0. So that,
Okay.
yeah, so that is mutual exclusion, and there is something called as mutually exhaustive events. So if the union of two events, like say A and B, say A is 1, 2, 3, and B is 4, 5, 6. So the union of two is 1, 2, 3 up to 6, which is nothing but the sample space. So if the union is equal to sample space, in that case the events are called mutually exhaustive. Now coming to the probability part of it. So what is probability of event A? This is the notation for probability.
3, 1 by 2.
Yeah, so how it is calculated?
1, 2, 3 are 3 events. Total events are 6. So 3 by 6 is 1
No,
by
no,
2.
this is an event, like getting a number from 1 to 3. This is an event.
Yes.
Okay, so these
Yes.
are the possible outcomes in that. Okay,
Okay.
into sample points. So it is the number
Okay.
of sample points in A upon the total number of sample points in the sample space.
Okay.
Yeah, so it is 3 by 6, which is nothing but
6.
1 by 2.
Okay.
Okay, now
Uh,
similarly probability of B will be number of
uh,
sample
1 by
points in
2.
B, which
1
will
by 2.
again be 1 by 2. Now what will be probability of A intersection B in this case?
0.
Yeah, 0, because number of elements in A intersection B, it will be first of all number of elements in A intersection B upon number of samples elements in sample space, and this is 0, this is 6, and it is 0 hence. What if like my event A were like 1, 2, 3, and B 3, 2, sorry, 3, 4, 5. So what will be probability of A intersection B?
1 by 6.
1 by 6.
Okay, so it will be number
3,
of
3 is
elements.
common and total number is 6. So 1 by 6.
Okay, yeah, that is right. Is there anyone who is not getting it? Like I'm covering very basic things. So these are important
Uh,
for the next later steps. So please
yes.
feel free to interrupt and ask any queries you may have.
Sir, one thing I want to ask,
Huh.
do you have any WhatsApp group where we could share the problems that we are facing?
Uh, I don't have WhatsApp group, but on the Swayam portal you can check. There is this ask a question option which will redirect you to a discussion forum. You can ask your queries over there.
Sir, if you could make a WhatsApp group, then it will be better because
Sorry, like I'm actually not a regular TA of this course. Like I'm only assigned the online part of it, like the live session part of it. So
okay,
I mostly won't be able to like take the questions
okay,
outside
okay,
of this.
okay, no issue. I'll ask the question on the portal itself.
Yeah, yeah, please do. Like one of the,
And sir, is the video right now? Are you recording the video? It
yes,
will be
yes,
shared also.
yes, yes, it will be shared on YouTube. So let me just share the YouTube channel link.
Yeah, kindly share it.
Yeah, just a second.
Sir, one question.
Mm-hmm.
Sir, if two probabilities are equal and non-zero,
Mm-hmm.
So can they be mutually exclusive and
Yeah, so in this
in,
case, if you see in this case, in the previous case,
independent? Sim.
yeah, we'll come to the independence part of it. So in this case, you can see the events are mutually exclusive and their probabilities are same, 1 by 2, 1 by 2. So this is possible to have mutually exclusive events with same probability.
And they can be
Yeah, so that brings us to the question. Like the question was, can two events be both mutually exclusive and independent?
yeah, yes.
Yeah, so that's what like the question was asking. So now let me come to that. So it is if you see in the Venn diagram, so this is the intersection area. This is event A, this is event B. So in terms of area, it will be this area of this intersection part upon total area or sample space, if sample space is also having data points that are not in A and B. Okay, so that
It
was
is just like inner join in SQL, right?
inner join in SQL. I don't exactly remember. Sorry, like inner join. How do you define inner join in SQL?
The common of two sets, or
Okay.
basically two data sets.
Okay.
Yeah.
Yeah. So commonality will be intersection, and
Yes.
the probability of that event, like the intersection of two events, will be the number of elements or the sample points that you have in that intersection upon the total number of sample points in the sample space. So
Okay.
yeah, so now this is fine.
Yes, sir.
Yeah, so now conditional. Let me discuss the conditional probability. Now, how do you define probability of A given B?
So probability of A intersection B upon probability of B.
Okay, this is fine. Probability of A intersection B upon probability of B, but how will you read it? Like, what is the meaning of this probability of A given B? Can you just explain it verbally? That what does it mean?
Sir, it means that the event B has uh,
Mm-hmm. Yeah, you are on the right track.
uh, so
Yeah, so
actually
let me
I am not
explain.
able to get it,
Yeah, yeah.
so I
So
forgot.
what it means that event B has already occurred.
Yeah, yeah.
Yeah. Now you are restricted to only event B. Your sample space is now event B, like the subset of the sample space. It is
Yeah,
known as
yes.
reduced sample space. So event B has already occurred. Now what is the probability of event A? So here A is 1, 2, 3, 4, and B is 1, 2, sorry, 4, 5, 6. So probability of A given B will be probability of A intersection B upon probability of B, which is nothing but what is the probability of A, what is A intersection B?
A intersection B, it is 1 by 6.
Yeah, so probability of A intersection will be, let me dump it down further. So it will be number of elements in A intersection B upon total number of elements in the sample space, the original sample space, upon number of element in B divided by number of element in sample space. So this will get cancelled out. So it will be basically number of elements
1
in
by 3.
A intersection B upon number of elements in B,
1
which
by
is
3.
1 by 3.
3.
Yeah. So in terms of Venn diagram, say this is event A and this is event B. So the question is, like, B has already occurred. So this is our reduced sample space now. Now what we are asking, what is the probability of A in this reduced sample space? So it will be this area, red area, divided by the yellow area.
The total area.
The total area of B, only B. We are restricting to B.
Okay. It is just like right outer join in SQL.
Okay, yeah, I totally forgot about SQL. Like I did it during my undergraduation, and after that, like
Yeah.
I never used it. Actually, sorry for that.
Yes, because in data science, sir, actually SQL is also used frequently. That is why I'm trying to remember it also.
Okay,
It is using the same concept right now, whatever you are telling, like doing Venn diagram.
okay, okay. Thank you for
Yeah.
that, Saurabh. Yeah, fine. So this was all about intersection and the conditional probability. Now, sorry, yeah. So this formula over here, probability of A given B is probability of A intersection B divided by probability of B. So you can write now probability of A intersection B as probability of A given B into probability of B. Is it clear? It's just taking this here. Similarly, you can also write it as probability of A intersection B as probability of B given A into probability of A. Is this clear to everyone? Any query in this?
Can you please explain second one?
Yeah. So second one, it's simply probability of B given A is probability of B intersection A upon probability of A. And probability of B intersection A is nothing but probability of A intersection B. Both are the same thing.
Okay.
Yeah. So hence probability of A intersection B is probability of B given A into probability of A.
They are mutually exclusive.
We'll come to that. It is irrespective of mutual exclusion.
Okay.
Okay. Now, if the two events are mutually exclusive, so their intersection is 0, right? Probability
Right.
of A intersection B will be 0. Now we have, let us have this formula also like in our mind. Probability of A intersection B or let me write it as this. Okay. So if both the events are mutually exclusive, both of this probability of B given A will be equal to probability of A given B equal to 0, because the numerator itself is 0, and the condition should be probability of A should be greater than 0 and probability of B also should be greater than 0. This should not be like null set. Okay. And properties of probabilities are like probability will be between 0 and 1. This is strict inclusion. It can be 0, exactly 0, which is like highly non-probable event, and probability 1 means highly probable event. Now the condition should be P of A and P of B should be greater than 0, and if the two events are mutually exclusive, their conditional probability will also be 0. Okay. Now coming to the independence of it, part of it. So I have if my event A is when the two events A and B are occurring, when you take the conditional probability of A given B, but if the two events are independent, like A is not dependent on B, then conditional probability of A given B will be probability of A only, because it is not dependent on B. Okay. Similarly, conditional probability of B given A will be probability of B. So, if you see in the example, like it will be probability of A intersection B upon probability of B. So, what you say over here, probability of A intersection B will be probability of A into probability of B. Is it clear? Is it clear to everyone?
No, sir. Can you
Yes,
please
sir.
repeat?
Yeah. So, see, when two events are independent, event B
Okay.
has occurred, but event A is independent of event B.
Hmm.
So, the probability of A does not depend on the probability of B, it is independent. Hence, it
Okay.
is nothing but probability of A. It is irrespective of B. Whatever is happening in the event B, we don't care. And similarly,
Okay.
probability of B given A, when A and B are independent, it is probability of B only. Okay.
Okay.
And from the previous equations we saw, like probability of A given B is probability of A intersection B upon probability of B, and then probability of B given A is probability of A intersection B upon probability of A. This is clear? We saw just now, right? Like this one.
Okay.
It's
They
clear.
will be
Yeah.
they will be cut.
Yeah. So now probability of A intersection B will be, in case they are independent, it will be probability of A into probability of B.
Okay.
It's simply like I am taking this denominator over here.
Um, I can understand in terms of what should I say? AND gates in digital logic.
Mm-hmm.
1.0 0.1.
Okay. It's similar to AND, but what you are doing over here is like, okay, I'm not sure, like it will just confuse everyone, so let us not go into that discussion. So
Okay.
basically, probability of, let me just write it again, probability of A given B in general is probability of A intersection B upon probability of B. That is probability of A given the B has, even B has occurred, is nothing but probability of whatever is common between A and B upon the space of B. And if the two events are independent, this probability of A given B will be probability of A, because A is independent of B. Hence, probability of A intersection B will be probability of A into probability of B. This is the case when the two events are independent. Now, what we have seen is, if the two events are mutually exclusive, probability of A intersection B will be 0, right?
Right.
Okay. It means that probability, like now, if they are independent and mutually exclusive, so ideally it should be probability of A into B equal to
Is
0.
equals to 0. Then one of them
One of
should
them
be
should
0.
be 0, but which is violating the condition that the probability should not be 0, right? Either of the probability should not be 0. So, as we discussed over here, so probability of A given B, B given A is probability of B intersection A upon probability of A, probability of A intersection B upon probability of B. So, if this denominator cannot be 0, else it will become non-defined. So, this cannot be this won't be possible that an event is mutually exclusive as well as independent. So, this thing cannot occur together. That's what I was trying to say. It is a bit confusing, I understand, but yeah, just work on it like on pen and like on paper, so it will be like pretty like clear to you.
You were telling about 1 upon 0 is not defined.
Yeah, 1 upon 0 is not defined. They generally write it as infinity, but yeah.
Infinity, yeah,
Yeah.
but that is actually the confusing part because I know that it is infinity.
Yeah.
How?
So basically probability, uh, yeah, so probabilities cannot be infinity, right?
Yeah, no, they can be only between
0
0
and
and
1.
1.
Yeah, so if it is 0 here, p of a given b will be infinity, so which is not possible.
Pardon? Can you please repeat? What
If
are you saying?
p of b is 0, p of
Yeah,
a given b will be infinity, which is not possible.
okay,
Yeah, so p of b should not be, and by definition it should be like between 0 and 1, so hence p of b cannot be 0.
okay.
Yeah. Any query? Yeah, please give.
So somebody has raised the hand.
Yeah. Who is that person? Sudha Rajakumar. Yeah, please go ahead, ask your queries. Okay, I think that is raised by mistake, so we'll go ahead. Let me share the screen again.
The last part was actually confusing, sir.
Okay. Okay, we'll see that. Like I urge you, like you go back and also try yourself, like
Yeah, I
yeah.
think I'll have to go back to basics for
Yeah.
that.
Yes, so it is very important to have all these basic things clear. So this 2 hour session is like not sufficient actually to cover all the things, but I'll definitely urge all of you to go back to the recordings or some other sources and then try
Yeah,
to figure out this basic thing.
yeah, so that is
In
why
fact,
I was asking about making a WhatsApp group so that I can ask the queries that will occur while going through the videos also.
Yeah,
That
yeah.
is why I
So
was
I'll
asking.
I'll
in,
I'll recommend you one thing. So whenever you find it difficult to understand anything, just go to YouTube and search for that concept. There will be n number of videos explaining the concept. For example, let me just search uh, independence of two events. So go ahead, please be on mute. Please make sure that you are on mute. Okay. So if you just search this, you will get n number of videos along with some problems, like solved problems. So yeah, you can go ahead and look into any one of that and try to clear that concept. So just look into the YouTube and then search for whatever queries you have. For example, introduction to probability. Excuse me, please. Uh, Sorry, I'll have to remove this person. I hope it is Sujit. Can someone please confirm?
Yes, sir, it's him.
Yes, sir.
Okay, so I'm just removing the person for the time being. Sorry, Sujit. Since it was creating disturbance, I had to remove you. Okay, so introduction to probability. So if you just search this, you will get lots of videos over here. So do look into this online resources whenever you are having any queries. So you don't have to like be dependent on these online sessions or the uh, lectures delivered by Professor Ramesh. You can always look into other resources to clarify your queries. And there
Okay,
are
the topic is broken into
yeah.
subtopics, right?
Yeah, and there is a very good channel called JB Statistics. Let me just search if it is there. Yeah,
Uh,
basics of
part,
probability. So let me
Pardon,
just
sir. What's the name?
yeah,
I can write it down.
I'm just sharing the link to that channel.
Okay.
So it is basics of probability. So you will get a very good hold on probability if you carefully look into these videos. So it has like all other basics like union, intersection, and then the conditional probability and how independence look like on Venn diagram and so on. So please go through them, and there are like multiple visual examples which will help you understand like or grasp the concepts in a better way. So
Okay, sir.
yeah. So after this class, please do go through it. It will be difficult for me to cover all these basics, but yeah, you definitely can look into other resources and get your doubts clarified.
Okay, sir. Thank you.
Yeah. So let me go ahead. So two events having non-zero probabilities cannot be both mutually exclusive and independent.
Uh,
Yeah. So this is the answer. So if they are mutually exclusive, P of A intersection B is 0, which means like as we saw, P if two events are independent, P of A intersection B is P of A into P of B. And if they are mutually exclusive, P of A into P of B is 0 and either one of them should be 0, which is not possible because it is also given like these are non-zero probabilities. So the answer is cannot be both mutually exclusive and independent. I understand it might be a bit confusing for you, but please go through the videos that I shared just now, and it will be crystal clear after that.
yeah, that is what I'm trying to understand from past 10 minutes why it is
So
like to.
just keep that aside. Maybe like we will go to the other concepts, and you can look at your own pace.
Okay, sir.
Yeah. Okay. A club of four. Next question. Let me stop the share and share the tab.
So you have taken any class related to permutation and combination till now?
Have not taken any, but maybe I can just discuss very basic of permutations and combination if you want.
Yeah, sure. Because some of the questions that we are going to face, they will
Yeah,
be
this
depending
question is
upon the.
also dependent on that.
Yeah, that is why I asked about it.
Okay.
I studied in I think I studied
Okay, fine,
probability
fine,
maybe
fine.
in
So
seventh semester.
let us discuss, Saurabh. So I'll just go on to. So the question is, club of four is to be selected from a group of 12 people. How many possible clubs can be selected? For those who know, you can answer now, and then I'll explain it for those who do not. Okay, how many of you, by the way, do not have any background in permutations combinations? You can raise your hand.
Very less at the moment.
Okay, fine. Okay, we'll.
I do have the background, but I'm unable to recall it, sir.
Okay, yeah, we'll discuss it from the basics. Okay, one person says Priyadarshini. Okay, for others who know about it, please bear with me. I'm going to discuss very basic things, but yeah, it will be helpful for those who are not. Okay, I hope my iPad screen is visible now.
Yes, sir, it is
Yes,
visible.
sir. Yes,
Okay,
sir.
so let's say there are certain events occurring. Say you have like mm, two numbers, or let's say H and T, two options H and T. So in how many ways this particular position can be filled?
Two.
Two, right? So
Hmm.
this two. And what about the other?
Two.
Two.
Now you will have to ask, is it without replacement or with replacement? Now
Yes.
the question is, are we, if we fill up this place with certain input from this, are we going to keep that input back and use it again or not. So here we
No,
can
sir.
have H and T. So it depends on what you are going to do. If it is with replacement,
Hmm.
you can have HT over here and two possibilities HT over here.
Hmm.
So the total number of possibilities will be 2 into 2.
This is
4.
with the 2 coins.
This is with the 2 coins.
Okay.
If there are 3 coins, sorry, I'm tossing 3 coins.
So it
For
will be 8 possibilities, 2 into 2 into 2.
Yeah, so in first position I have 2 possibilities, in second position I have 2 possibilities, and in third position I have 2 possibilities.
Yeah,
So it will be total 2 into 2 into 2. It
it will
is also
be like,
clear from the tree diagram. So in tree
yeah,
diagram
it
you will have
will be
HT.
HHH, HHT, HTH, just like that. It will be
So
treated.
if you draw this tree diagram, it will be very clear to you. Like,
Yes, sir.
yeah,
Now I can recapitulate. Now I can understand this.
yeah. So this was without with replacement. Now if it is like without replacement, like in the case of 2, in 3 it cannot be, but in the case of
2
2,
and 1.
so it will be 2, and now you only have one option left, so only one option can be filled over here.
A silly question.
Mhm.
What do you mean by replacement?
Replacement is, say you have a bag and this bag is containing H and T, two options. Now in the first place you can have H as well as T. So if you take H over here, you will only have T left in the bag. You are not putting the H back into the bag. So that is known as replacement. So if you are putting it back into the bag, that is replacement.
Okay.
Yeah.
Similar to the ball problems, like we have red, green, and blue balls in
Yeah,
a bag.
I have that question, Saurabh, in later part. So we'll discuss that as well.
Okay, sir.
Yeah.
Now about the permutation and combination,
Yeah.
sir.
So permutation and combination. So say I have 3 people or 3 numbers, 1, 2, 3. So the permutation, okay, of this, okay, let me take more. I have 3 positions and I want to select 3 numbers from this to create a number, 3 digits from this to create a number. So in first place I can have
7.
7,
Uh,
then this is without replacement,
Without replacement, 7.
7, and in second position I am left with how many options?
Without replacement or with replacement?
Without replacement.
6.
Here 6. Now I am left with how many options?
5.
Yeah,
5.
yeah. So the total number of options will be, I am be having is 765, right?
Yeah.
7 into 6 into 5, which can also be written as 7 into 6 into 5 into so on till 1 divided by 4 into 3 into 2 into 1. Is it clear?
Okay.
So this particular,
So it is known as
but
permutation
this is
or
permutation.
combination.
This is
This is
permutation. Yeah, so this is
okay.
permutation. So what is happening over here? In first position I can select 2, 1, 2 and 3. These are 3 positions, and I can also select 1, 3 and 2. Okay. So this is one option and this is another option.
Okay.
Yeah, so this both are valid. When the order matters, like order of the number matters, in that case it will be called permutation. You are permuting the numbers. So here this is represented as, so this is 7 number of total elements, and out of
Hmm.
that I am having 3 positions. So I have to take build a number with 3 digits. So it can be written as NPR, which is n
Right.
factorial divided by n minus r factorial.
R factorial into R factorial,
That
it
is
will
combination.
become
That is combination.
combination.
Let me come back to that. So here this thing is nothing but this 7 into 6 into 5 into 4 into 3 into 2 into 1 upon 4 into 3 into 2 into 1. So this is like getting cancelled out. It's 765. So it's n factorial upon n minus r factorial. So this thing is known as permutation. But if I say I don't bother about this order, for me 1 2 3 and 1 3 2 it's the same thing. Like if these are three people and I want to form a committee. So in committee, let's say there are three people, Saish, Rohan, Durga, or Saish, Durga, Rohan. That's the same thing. It doesn't change the committee. So in that case, that r factorial terms come into picture. So n factorial, n minus r factorial are the total number of such possibilities, and then I want to delete these duplicates, take care of these duplicates. So those will be r factorial times. Now how it is done, again I'll ask you to go to the basics, like look into the details online and clarify these doubts. But yeah, so this particular term is known as combination, which is represented as NCR, or also like in parenthesis with n written over here and r over here. Uh, is it clear? Like at least to some level, like anyone?
Can you just in one statement
Okay,
explain
sir.
again what is permutation and combination?
So
Just in one statement.
okay, so let us see uh, in permutation and
Sir, I'm
combination.
little bit confused related to this 1, 2, 3. I am unable to understand this. What are we basically? What are we doing?
So
Can you
basic
please tell? Yeah.
permuting something, it's like you're taking out of the available options, you are taking some number of options. Okay, so I have say 5 numbers and I have
Uh,
3 positions.
kindly use balls case. Red ball, green ball, blue ball. Can you use that case? I can understand that.
But in that case, I'm not sure if you will be able to understand, because it will be okay. Let me check R1, R2, G1, G2, G3, B1, B2.
Okay.
Okay, so this position can be filled by how many options? Now I have like 1 2 3 4 5 6 7, 7 options.
Yeah.
7, right?
Yeah.
This can be filled by the left 6 options,
Yeah.
and this can be filled by the rest
The left 5
5
options.
options. Okay, so total number of ways it can be filled is 7 into 6
7
into
to
5,
6 into 5.
which can be written as 7 into 6 into 5 into 4 into 3 into 2 into 1 upon 4 into 3 into 2 into 1.
Why we are using upon
Upon,
4 into
because
3
we
into 2
want this, we want to represent the numerical and the denominator numerical in the terms of factorial. So 7 into 6 into 5 into 4 into 3 into 2, it will be 7 factorial,
it will be 7 factorial,
and
right? But
this will be
why
4
why
factorial.
we are why we are dividing it by 4 factorial?
Because
That
our we want this, we are dividing and multiplying by
N
the same
minus
thing,
R.
so that this gets cancelled out.
N minus R factorial.
So this gets, the numerator part and the denominator part will get cancelled out. So the thing that will remain is will remain is 7 into 6 into 5.
okay.
Yeah, so this is nothing but 7 factorial into 7 minus 3 factorial, and then this 3 is the number of positions we have.
Okay, it is n factorial divided by n minus r factorial, right?
Yes.
This is what permutation is all about.
Yeah, permutation is all about. So here, so what is happening? In the first position, you can have R1, R2, G1, or you can have R1, G1, R2, right?
Okay.
Yeah. So this, when the order matters, then you use permutation, but when the order doesn't matter, like when you consider these things are as same, r1 r2 g1 and r1 g1 r2, this is a
Just a minute. It may be R2, R1, G1.
yeah, it can be r2 r1 g1, and it can be r2 g1 r1, or it can be g1
Right.
r2
B
r1, it can
and
be g1 r1 r2 and
blue ball.
r1 g2 r2 and r1 r2 and
Even
g1. So all these possibilities are there, right?
the blue balls also.
Yeah, blue balls also, but I'm saying the options in which r2 r1 and g1 are there.
Okay. So the
So
order actually does not matter in
so
permutations.
in permutation order matters, but in combination all these things are same.
Okay.
Okay, so in that case you have this extra term of r factorial, in this case 3 factorial. So what is this 3 factorial over here? 3 into 2 into 1, which is 6. So are you seeing these are the 6 options, right?
Right.
Yeah, so these 6 options are considered as only one option, that's why we are dividing it by r factorial, extra r factorial over there. So it is n factorial n minus ncr is n factorial n minus r factorial divided by r factorial. So what it means is taking 4 objects from a set of n objects, where order of the 4 objects does not matter. And in this case npr, which is n factorial upon n minus r factorial, it means taking 4 objects from the list of n objects, but their arrangement matters, like how these 4 objects are arranged. So here in the case of permutation all these are different, but in the case of combination these 3 objects are the same, their arrangement does not matter.
Okay.
Yeah, so that's why this extra r factorial is coming, because there will be r factorial such possibilities of the elements, because you have 3 positions, right? See, r is 3 and you have this g1 r1 and r2. So these are 3 options first, and then in the second place 2 options and third option. So it will be 3 into 2 into 1, which is 3 factorial, right?
Right.
Yeah. So what we had over here, this all these possibilities. So first r2, then r1 g1 r2 and g1 r1. So second thing g1 r2 r1 g1 r1 r2, and then so in the first place I can have either r1 g1 r1 r2 g1 r2 r1 r2 and g1, any 3 of them, any one of the 3. And in the second place I can have the remaining 2, and in the third place I can have the left one. So that's why this r factorial such possibilities are coming, and we are dividing it by r factorial because we consider them all as same in the case of combination. Is that clear?
Yes, sir.
Okay. So if it were like four such terms, for the same case, like I have 7 balls and I have 4 positions.
So it will be 7 into 6 into 5 into 4.
Yeah, so it will be 4, which is nothing but 7 into 6 into 5 into 4 into 3 into 2 into 1 divided by 3 into 2 into 1, which is 7 factorial upon 3 factorial, which is 7 factorial upon 7 minus 4 factorial, n factorial n minus r factorial.
Okay.
Okay, but for if you take any 4 balls from this, so for those 4 balls can be arranged in how many ways? 4,
It is
3, 2.
sorry,
Factorial.
if some condition is applied, like we choose a red ball, what is the probability of choosing a red ball and 2 green balls and 1 blue ball.
So in that case, you will have to have the order. You mean like you second position it will be green ball only. Is it that is that the question you are asking?
Yeah, one place should be red,
Hmm.
one place should be blue, and 2 place should be green. That is what the problem is.
Okay, one place should be red.
Any place randomly. I am talking about a conditional probability. In this, what should be the how we will find out that?
Okay. So this was all about arrangement. Now your question is different. So you are saying like in one place it should be red, in one place it should be green, and the other two places it should be blue.
2 green, 1 red, 1 blue.
Two green, one red, one blue.
Yes.
Okay, so that is again a bit complicated one. Maybe like yeah, I am not sure if I will be able to cover other topics if I go into the details of that. But I can just tell you that in that case there will be like multiplications of combinations that you are doing. So you are first of all taking uh, one rate out of two rates.
Okay,
So
so
it will
it
be
will be
2C1
okay.
into, then you are taking one green out of three greens or two greens out of three greens. So it will be 3C2,
3C2,
and then one blue out of two blues,
2C1.
1. Yeah, so this will be this multiplication. But yeah, let others please don't get confused because of this. So this is the way you can get uh, yeah, the condition that you have set. Like you want two red balls and two green ball, one red ball, two green ball, and one blue ball.
Thank you, sir.
Yeah,
I
but
wanted to recapitulate this topic.
yeah, but yeah, let us also keep this in mind. Like others are there, so they are also means they might be getting confused. Yeah,
Kindly go through the basics only for
yeah,
others.
yeah. So yeah, let us
Remember that topic, that this is the topic that is frequently used in the probability actually.
yes, yes. Okay. So let me go back to the question now. Okay, let me
We
put this
are
question. Let me put this question over here.
12. The question was about how many ways we can choose 4 from 12. That was something you told in
Okay,
the slide.
sorry. I pasted the link again. Let me paste the question over here. So the question was, a club of 4 is to be selected from a group of 12 people. How many possible clubs can be selected? So if
What do you mean by club?
club is like a committee.
Okay, a small group basically.
Yeah, a small subgroup is to be selected from a group of 12 people. So how many
Oh,
such groups are possible? From a
uh,
group of 12 people. So there are
12,
12 people and we have 4 positions.
12C4.
Yes, that is correct, but others, are you getting it?
So it will be 12 into 11 into 10 going up to 5. And the denominator will be 4 factorial. It will cut it and it will be 12 into
No,
uh,
no, I'm asking others like if they are getting this concept, like what?
okay. Sorry.
Yeah, yeah. So is it clear to
Yes, sir, we
everyone?
understand it.
Okay,
Yes, sir.
yeah. Is there anyone who did not understand what is happening over here?
So this is a combination problem, right?
Yes, it is a combination because when you are taking a committee, so say a committee of person A, B, and C. So the order of persons in the committee doesn't matter. Committee containing A, C, B, and committee containing, it's like committee containing you, me, and someone else. So you can say in any order, someone else, you, me, you, someone else, me, someone else, you. So it's the same thing, right?
Okay.
Yeah. So there,
Whenever they are saying that it should be in order, it will use permutation.
and when
Otherwise,
otherwise it
there
will
will
be combination.
it will be a combination.
Yeah.
Okay, sir.
Okay.
So should I? So what are the options for this?
So it is 12 factorial, 12 minus 4 factorial, and 4 Okay, let me share my screen.
8 factorial into 4 factorial. So it will cut 12 into 11, 12 into
Okay,
11 into
Saurabh,
10 into.
let us skip that part. Means like a computation, you can, I leave it to you, so you can do
Okay,
it.
sir.
So it will be 495.
Okay, the answer, the options are
395. I'll be sharing these slides with you, so you can practice at your own pace later.
so where are you going to share them?
Yeah, it will be in the Google Drive link. So the link will be like if you visit my YouTube channel.
Okay,
Just a second.
1 second.
Yeah, I hope my screen is visible. If you visit my, so this was the second session recording. If you visit this, you will find the link to the drive folder over here. So
Pardon, sir.
are you able to see my screen?
Yeah, now
Yeah.
I.
Yeah, so if you just go over here to on this, like I'll be uploading this video and there will be a link in the description. So if you go to this link, there will be a drive folder which is having all the material that I'm using for
Okay,
these weeks. So for week 2 you will be finding the slides of week 2 and the notebook, Python notebook that I have used.
okay, sir.
Okay. Yeah, so for week 3 I'll be uploading all the material over here, so you can
We
continue.
have to download for the Python notebook. We have to download Jupyter notebook.
No, it is on it is Colab notebook, so you can use Google Colab. I'll come to that.
Okay. The code is already written on this.
Yeah, so I'll be having pre-written codes on that, like, so for example like this, so I'll be sharing all this with you, so you can just simply run and then experiment with that.
Okay, thank you so much, sir.
Yeah.
Yeah. So the answer is 495.
Yes, I'll be sharing this with you, so I'll leave the computation part to everyone. The main part was explaining the concept, so I hope that is clear to everyone. If not, like, I'll urge you all to go back and then look into some other sources on YouTube which will be covering all these permutation combinations. Yeah, I'm sure there are like very good videos on each of these topics, so you can go and then look into those. Yeah, so next question. 8 individuals are candidates for position of president, vice president and treasurer of an organization. How many possibilities of selection exist?
8C3.
Okay, are you sure?
The 8 individuals are candidates for position. There are 3 positions.
3 positions,
President.
but each position has a notion attached to it. President, vice president and treasurer.
Okay, so it will be a permutation problem or combination.
Okay, I have this question to everyone. Will it be a permutation problem or a combination problem? Can others answer in chat or unmute themselves and answer? So I have 8 people and I have to form a committee of 3 people, but I have a position attached to each one. Like there should be one president, one secretary, or what was it? President, vice president and treasurer. Yeah. So some are saying permutation, some are saying combination. So the right answer is permutation. Why? Say I have 3 people, person A, person B, person C. So person A can be president, person B can be vice president and person C can be treasurer. And then person A can be president, person C can be vice president and person B can be treasurer. So here the order matters. It's not like person A, B, C. I'm just simply forming a committee, but in that committee I have these positions where the order matters. So you will have to have permutation in this case. Is that clear? Yeah, so I hope Saurabh that is clear.
Yeah, the order actually matters.
Yeah, so
First,
the order matters over here, in which you are having 3 people. One will be president, one will be vice president and third one will be treasurer. So it will be 8P3.
8P3, right?
Yeah. So answer is 336. You can just solve it later. Okay, a college plans to interview 8 students for possible offers for graduate assistantship. Please be on mute, everyone. A college plans to interview 8 students for possible offers of graduate assistantship. The college has 3 assistantships available. How many groups there can the college select?
It's a combination problem, I guess, because both three places are graduate assistantships only.
Yeah, so here the order doesn't matter, hence it's a combination problem. So out of it you are selecting 3 people, so it will be 56, 8C3. Now
Earlier on, it was vice president, president, and
treasurer, so there the order mattered, but in this case order doesn't matter.
so the first position will be filled by the president, second will be vice president, third will be treasurer, right?
Yes,
That is why it's a permutation problem.
yeah,
And
in this
all
case all the positions are same, so it doesn't matter, order doesn't matter.
okay, sir. Okay.
Okay, a company plans to interview 10 recent graduates for possible employment. The company has 3 positions open. How many groups can there? How many groups of 3 can the company select?
For possible employment, they
Yeah,
are not.
Saurabh, I want others to answer now. I think you have understood.
I'm asking something about the
Okay.
question. They are not telling about the positions.
Yeah. So a company has 10 graduates for
So
possible employment, and company has 3 positions open, and the positions are same.
positions are same, na?
Yeah.
Okay, sir. Okay.
So since there is no mention of the positions like president, vice president and all, so it's a combination problem again. Now this is a tricky question. A bag contains 1 ball. You might not get such kind of questions in your NPTEL exam, but this is just to have some hands-on on probability questions. A bag contains 1 ball which could either be green or red. You take another red ball and put it in this pouch. You now close your eyes and pull out a ball from the pouch. It turns out to be red. What is the probability that the original ball in the pouch was red? Now this is very a bit confusing. It involves lot of things, but yeah, let us kind of skip this part for the time being. You will discuss it in detail, like if you don't understand it, but the answer is given in the next slide. So I'll I urge everyone to go back to the slides. I'll be uploading the same to the drive, and then solve it yourself. Like take time, understand it, and then solve it, and then go to the answer. Don't look at the solution right away, because it will just simply won't help you to think if you just simply see the answer right away. So think over it.
So here is given two ball. One is red and one is green, and we are
So that
adding
is
one
already,
another.
yeah, that is already there in the bag. Now you are
Okay, and we
adding.
are adding one more ball. So we
Yeah.
have a three ball, and we have to select
No, 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 no,
any one ball.
no, no, no. The first ball can either be green or red. It's only 1 ball that is there in the bag, which can be green or red.
Okay.
Yeah, and then you are putting a red ball on top of it, like in that bag.
Take another red ball and put it in this
Pouch.
pouch.
Yeah. Now there are 2 balls in the pouch. One
Two
can
balls.
be either green or red, and other one is definitely red that you have put in.
Okay.
Yeah.
So
Okay.
Yeah.
so we have
So
a
yeah,
two red ball and one green ball in the bowl.
No,
No,
it
no,
will
no.
be
It will be 1 ball. There will be 2 balls, out of which one is the one that was already present, and it can be either green or red.
Okay.
And
the
then
first
अगर
green.
अगर उसमें red है तो there will be two reds, so it will be 100% probability.
no, 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 no.
No, no, no.
No, so it will depend on that. Okay, let me just discuss this question. Maybe since there is a confusion, let me stop the share. I'll share the that screen.
Yeah.
Saurabh, I think there is some noise from your end. Can you please be on mute?
Okay, sir. Okay.
Yeah, thanks.
Can you please share the screen, sir? I'm
Yeah,
unable to see
I'm
the.
sharing. I'm sharing. Okay, so the question is, I have a pouch, and the pouch contains a ball. It can be either red or green. So both possibilities are there. So I am just making one only. So it can be red or green. what I'm doing, I'm putting one more red ball in this, explicitly having one more red ball. So the first ball, this is ball 1, say, oops, sorry, this is ball 1 and this is ball 2. So ball 1 can be red or green and ball 2 is definitely red. So I am having only 2 balls. Now what I am doing, I am closing the eye and taking out the ball out of it. It can be either ball 1 or ball 2. I can take out ball 1 or ball 2. So what is the probability, what question asks is, what is the probability that the original ball in the pouch was red? That is, what is the probability that B1 was red? So what are the outcomes? What are the cases, like you have taken ball 1 or you have taken ball 2?
Okay.
Okay, what is case 1?
Selected ball is
Ball 2.
1.
Okay, selected ball is 1.
1. Then is the probability is 1 by 2.
No. Selected ball is 1 and its color is?
Red, green. The probability of red is 1 by
Okay.
2.
And
So
okay.
is a 1 by 2.
Okay.
Maybe is a red or maybe is green.
Okay, selected and in bag. Okay,
Uh,
selected is B1 and it is green, and in bag it is red. Case 2, selected one is B1 and its color is red, and in B2 it is red.
Sir, do we have 2 balls in the first place?
No, we have only one ball and it can be either red or green.
So how it can be selected is green and in bag is red?
Yeah, that is the second ball is what we are putting again. B2 is the ball, red ball that we are
After
explicitly adding.
that the case 1 is after putting the red ball in the bag.
Yeah. So that's what,
So
like you are putting this like B1 was already there, you are putting B2 and now you are taking out one ball out of it.
okay, sir.
Yeah, so the case 1 is the selected ball is B1, taken out ball is B1 and it was green already in color, and B2 was red. Means in back B2 is there, which is already red. Case 2 is B1 was taken out and it was red in color, and B2 is left in the bag, which is definitely red. Case 3 is you take out B2, which is red, and B1 doesn't matter. B1 is in the bag.
Okay.
Okay, so the probability that the taken out ball, probability that B1 was red. The question asks what is the probability that the original ball in the pouch was red. Is nothing
Case,
but
case 4 may also be there.
Is 1 by 2.
sorry.
Case 4. Case 4 will also be there.
No, case 4 you are taking out, no, the condition is, the experiment is you are taking out the ball which is red in color.
We are taking out 2 balls simultaneously or one after another?
One ball only, we are taking only one ball.
One at one place, one at one time. Okay.
Yeah. Okay. Yeah. So I've just given the context. Yeah. Please think over it. We'll discuss the answer maybe in the next session for this. Yeah. This is just to like give you kickstart, like to.
The answer is 1 by 2 is correct.
No, that's not a correct answer. Yeah, I won't show the answer right away, but yeah, I want everyone to think on it, and then we'll discuss it in the next session.
We have to just find out the probability that the B1 is red. Na? Original ball B1 is red.
Yeah, original ball B1 is red, and in how many cases B1 is coming out to be red, and then how many total number of cases are there. So please think over it.
Okay.
Yeah.
Sir, can you share the question on the screen so that I can take a snapshot of it?
Yes.
No. I'll be sharing the slides itself, so you can look into the question later.
YouTube channel, right?
Yeah.
After uploading
Okay,
the
only in YouTube channel, not in a WhatsApp group, sir?
No. In YouTube channel you can find it, like whatever videos are already uploaded, in that also you will find this link. So So
Okay.
it will redirect you to the same drive folder in which you will find.
Okay. Thank you.
Yeah, let me remove this first because it has like less number of questions. I'll just remove this and I'll re-upload like with the more number of questions what we have today. Okay. So
Sir,
now,
this was related to I can search on the YouTube also the videos. Can you please tell me the name of the topic that we were discussing? This question, this particular red ball and green ball.
yeah, so you can simply search problems on probability.
Problems on probability.
Yeah.
On
No, so there will be, so this I'm not sure where this problem was taken from. I don't remember the source exactly, but yeah, there are many such similar problems in multiple sources. So you can just search problems of on probability. So you will find n number of problems.
Okay, sir.
Yeah. Also, Saurabh, a request like so there is some noise from your end. Maybe you can go to some place so that it doesn't create any disturbance for others.
Uh, Actually, I am sitting alone in a room, sir.
Sorry, maybe it is the fan noise that is creating problem.
The noise of the laptop, actually.
Okay, sure. Okay, never mind. Yeah, so please be on mute like whenever you are not having any query. Thanks. So now the question is, suppose you have a biased coin, that is P of H is not equal to P of T. Like probability of head is not equal to probability of T. Ideally, unbiased coin will be probability of heads and probability of tails will be 1 by 2, 1 by 2, 50-50. But in this case it is given that probability of heads is not equal to probability of tails. So how will you use it to make unbiased decisions? Again, I'll leave it to you. Won't be discussing now. You think over it and then we'll discuss it in the next class. Okay, suppose you have a data about progression of number of cases of COVID-19 in some country during the second wave. What kind of visual representation would you prefer to use for the data? Okay, I won't be able to see the screen now like a chat, so please unmute and answer.
Pie chart, sir.
Okay, what about others?
Box plot.
No. What about others? Okay, let me just see the chat.
Sir, can you please share the question?
Yeah.
Yeah.
So suppose you have data about the progression of the number of cases of COVID-19 in some country during second wave. What kind of visual representation would you prefer to use for the data?
Pie chart.
No,
Sir, what is OGIF?
that is ogive. So
Ojai.
yeah, ogive is a plot. Okay, so the answer is ogive actually. Let me show
Yeah.
you what ogive is. So ogive is nothing but a plot of cumulative frequency.
Okay, it's like line chart actually.
So it is like this is known as less than ogive. So it is like how many students are having less than 20 marks, how many students having less than 30 marks, how many students having less than 40 marks, and so on. So the progression you can see like over here over time. So what the question was asking, what is the what kind of suppose you have a data of progression of number of cases of COVID-19. So the number of cases of COVID-19 are varying daily. So how many total number of COVID-19 cases are there till now? Like on day 1 I have 4 cases, on day 2 I have say 2 cases, so total number of cases will be 4 plus 2. Now on day 3 I have some 1 case, so it will be 4 plus 2 plus 1, total number of cases, active cases, and so on. So for that you use this ogive. It is nothing but a cumulative frequency curve, like how many less than 20, how many less than 30. It also includes this less than 20 plus between 20 to 30. Then
it is percentile also.
Percentile in the case when it is like divided between 100 1 and 100, yes, but it need not be percentile always. Say in this case there are class boundaries now. So how many are there between 1 to 9? This many. How many 1 to 19? This many. It need not be like, okay, let us see over here. This is the apt example. July, August. So you cannot divide it into as a percentile, like you cannot
Okay.
have it as a percentile. It is just simply a category that is there. So in July I had these many cases. In August, total number of cases including July were 1000 and so on. So this
Sir,
is
I'm
guidance.
unable to see the chart. Can you please do it in the full screen
Okay,
mode?
let me zoom in.
That it.
Oops, sorry.
I can see the image now.
Yeah. So here July, August, September. So what is it? Let us see. This is number of COVID cases. So COVID cases in July, total number of COVID cases till August and September and October. This also includes October also includes the number of COVID cases in September, and so on. So this is known as less than ogive, and there is greater than ogive as well, or more than ogive.
So, sir, what is the difference between a line chart and this ogive chart?
Ogive, it is specifically drawn for cumulative frequencies. So in this case it was how many are more less than this, how many are less than this, how many are less than this, and so on. And in this case what it is showing, how many are more than this, how many are more than this, and so on. So this is known as less than, and this is known as more than curve. So both of these are like ogive curves.
What are the different advantages over that?
Advantage over that, in certain cases you might be needing how many, it depends on the problem at hand. So if it is a classroom setting, you want to know how many students are performing better than certain threshold, like how many students are above 40. If that is the question, you use more than ogive. And if the question is how many students are having less than 30 marks, so you can just simply go to 30 and then find the number of students over there in the less than ogive curve.
Okay.
Yeah.
One more variable is added, like we have number of cases of COVID in a particular country for a particular year in month. If the number of deaths are also included, then what kind of chart? There
That will
should be
that will
dual axis also.
no, that will be a bit complicated chart, Saurabh. That won't be a simple ogive curve because there are
Okay.
multiple modalities involved in that.
Yeah, mortality also
Yeah,
included.
yeah. So it won't be a simple ogive curve. Yeah, we'll have to think over it, like what kind of diagram you can use to represent that. It can be simple bar chart as well. So you can have like the number of so it will be like a multiple ogive curves. One is representing the active cases, one is representing the mortality, and so on. So it will be like or either it can be like bar chart. So the number of cases in, or a frequency chart, a number of cases in July,
And a component also.
number of
There,
active cases and number of mortality, number of active cases, number of mortality, and so on. You can have like that as well, like two bars next to each other.
okay, sir. Having different colors to represent
Yeah,
different.
yeah.
Okay.
Bar chart with multiple values. Let me see if yeah, like this, something like this. So it is like the number of active cases, number of mortality, and number of recovered cases. So if you have this, you will have this for every month, and if you want to take a cumulative of it, so for each one of them, for number of active cases you will have a ogive curve, for number of recovered cases you will have ogive curve, and number of mortalities you will have ogive curve. So yeah, that is one sort of a representation that can be done. Okay. So yeah, what about the other ones? Pie chart, I hope everybody knows what pie chart is. Violin plot, this is something new. So in the last class we discussed about box chart or box plot. So violin chart is also similar to box plot, but the difference over here is, instead of a simple box, you see this curve over here. So this shows the kind of distribution there is. So if the distribution of the probability distribution of the data, it's like it kind of shows the shape of the distribution, basically how the data is spread.
Yes, the
Yeah,
shape is like violin.
it's not a violin shape. Actually, if you see it as x-axis, you see this this part. So this is the way the data is the probability. So let me just show distribution. We'll discuss distribution later.
Yeah, I had seen this in case of demographics of a country according to the age of the
Yeah.
population.
So in this you can see the distribution is
Is the
symmetric, right?
normal distribution.
Yeah, this is normal distribution.
Normal distribution.
And let me show you multimodal probability distribution. So you can see here there are two modes, right? So this is known as multimodal distribution. So if the data is spread like this, the shape of the probability distribution of the data is like this. We'll see what probability distribution is in detail, but if it is like this, then we get more information from the violin plot compared to the box plot. The box plot will simply show, like, let me just box chart and violin. So if it is box plot, you don't get the shape of the distribution, but if it is violin plot, you also get this extra information over here. That is how the data is spread. Like if it is a unimodal distribution or multimodal distribution, as we saw earlier, like this. Other things are same. The median will be here represented. Then the ages will be like the first quartile and the third quartile. This will be the interquartile range, and then this point will be like till over here. It will be like maximum. It will be 1.5 times the interquartile range, and else it will be like the lower bound and the upper bound of the data points. Yeah.
You have already completed box plot charts.
Yeah, I have already covered it in the previous session. So yeah, please go and look into that.
Okay, sir.
Yeah. You can also search it on YouTube. There will be like multiple videos explaining box chart and violin plot. Yeah. Okay. This was all about it and rest. Yeah. So next question is, suppose you have data about the preference of TV shows among viewers on an OTT. OTT is like on the go. I don't remember exactly what its full form was, but Netflix, Amazon Prime, Prime Videos, and Hotstar, and all these are all OTT platforms, and you have certain TV shows, say 1,000 TV shows. So suppose you have data about preference of TV shows among viewers on an OTT platform. What kind of visual representation would you prefer to use for the data?
I think violin will be good.
Not really. Like if there are like
Pie chart, sir.
yes, so it will be pie chart. In the case when you have less number of categories, say so if you have only limited number of categories, then it makes sense. Like say here, how many categories are there? How many TV shows are there? 1, 2, 3, 4, 5. 5 TV shows are there, and each one is having certain preference. So this particular TV show is preferred by 40%, and this is preferred by 10%, and so on. But let's say you have 1 lakh TV shows. So in that case, will pie chart be readable?
No, it is difficult.
Yeah, so there will be like very like short or tiny sectors over here, and it will be very difficult to read that pie chart. So pie chart is the answer in this case. But if there were like other options like bar chart also, so in that case bar chart would have been the appropriate answer, because in bar chart you will be having, so let me just show bar chart. For each of the TV show you will be having the count, the number of people who prefer this TV show. So this will, even if it is like 1,000 or 1 lakh such TV shows, you will get a clear count of each of those. It is visually like readable. So that is the advantage of bar chart over pie chart. Like in pie chart, if the number of sectors are more, it will be difficult to read. So in that case you prefer bar chart. So answer in this case is pie chart. But if it were like bar chart was the option, if bar chart was the given option, then that would have been the apt one. Okay, suppose there are 10 rabbits. This is the last question in the probability week. I am again like behind the schedule. Yeah, let us discuss this and then we'll quickly look into the distribution part of it, probability distribution, sampling and sampling distribution. Okay, suppose there are 10 rabbits in a race. Let R1 and R2 be 2 rabbits. If let A be the event that R1 wins, let B be the event that R2 wins. Are the events A and B independent of each other? You can quickly answer because I have to go to the.
Not independent.
Okay, one person. What about the others?
Suppose there are
Not independent, sir.
Okay, can you explain why it is not independent?
Because our rabbit one moves does not depends on R1 and it is not waiting for R2 also.
Sorry. Okay, let me just explain quickly. So, if a R1 wins, if rabbit 1 wins, then rabbit 2 does cannot win. That is the case, right? So, the winning of R1 decides if R2 is going to win or not. If R1 has already won the match, then R2 has lost it. So, the events A and B are dependent on each other. If R1 wins, then R2 is definitely a loser, means lost the match, and if R2 wins, R1 has lost the match. So, the answer is not independent. Okay, now let us quickly go to the second part of it. So, we have discussed introduction to probability, certain concepts relating to probability, then random variable. Oh god, okay, random variable is left. So, let me cover random variable quickly. Does anyone know what random variable is?
the value of the variable
Sample space.
we change.
Okay, I hope my screen is visible.
No.
Is my iPad
Yes,
screen
sir.
visible? Okay.
Yes, yes, it is.
Okay. So let's say I have this experiment of tossing 2 coins. So the sample space is HH, HT, TH and TT. Let's say I have event A getting at least 2 heads, then getting at least, event B is getting at least 1 head and C is getting no heads. So what is the probability of A?
1 by 4.
1 by
4.
what is the
1 by 4.
probability of B?
2 by 4, 1 by 2.
1 by 2.
At least. Please read the question. It is at least 1 head.
2 by
At
3.
least 1. So it's a 3.
1 by
2 by 3.
4.
It will be 3 by 4, right? At least 1 head. Here also it is at least 1. Here also at least 1. Right? So there are 3 such possibilities, and out of the total 4 possibilities. So it will be 3 by 4. And see, no heads. There is
1 by
so there is only
1 by
one
4.
choice. So this is 1 by 4.
1 by 4.
So what is happening? Let's say X is my random variable which denotes the number of heads. Everyone please be on mute. So random variable, it is a misnomer actually. It's not. It is called variable, but it is actually a function which maps the event to certain value. So let's say X is my random variable which denotes the number of heads. So probability of X equal to 1 2, sorry, X equal to 2 will be getting at least 2 heads, or let's say X is number of heads, probability of X greater than equal to 2, it is 1 by 4, probability of X greater than equal to 1, it is 3 by 4. Sorry, yeah, right. Probability of x equal to 0, it is 1 by 4, and so on. So what we are doing, we are converting this event, like mapping this event to a numerical value. So it is taking the event and having a corresponding numerical value on top of it. So this is actually a function which maps occurrence of event to a numerical value, and that is nothing but a random variable. In this case, the random variable was number of hits. So now in terms of distribution, so what is the value when x equal to 0, x equal to 1 and x equal to 2? So probability of getting exactly 0 hits, what will be the value probability?
1 by 4.
It will be 1 by 4. What is probability of getting exactly 1 hit?
3 by 4.
No, exactly 1 hit.
Exactly. 2 by 4.
1 by
3 by 4.
1 by 4.
I am not
1 by
asking
2.
at least 1 hit, I am saying exactly 1 hit. So exactly
2.
1 hit is only possible in these two cases.
Head, tail, and tail head.
Yeah, so this is exactly 1 hit. So the answer is 2 by 4, and then x equal to 2, exactly 2 hits, it is
1 by
again
4. 1 by 4.
okay. So this distribution of probabilities is called as probability distribution. So in this case I have drawn this as continuous, but it is not continuous, it is discrete in nature. So you can see the random variable is taking discrete values. Here in this case our random variable is number of hits, and for each of the random variable you are having certain probability associated. So you are mapping the random variable value or event to a numerical value or probability. So this distribution that you are seeing, which is like a histogram, is known as probability distribution, and it can be discrete in nature as in this case, or it can be continuous in nature. For example, height of person. So what is the probability of person having height, age or height or anything, so where the variable is continuous in nature? So height can be from ranging from 0 in some hypothetical world, no height, and then to some infinity, let's say. So there are multiple such possibilities. Probability of having zero height is 0. Probability of having some so as you go along, so there will be like more people having certain average number of height, and then it will decrease. Okay, so this is the probability. So every point over here is a height. Say let's say average height is like 150 centimeters. So 150 centimeter, there are most number of people in this world having this height. So this is actually the probability value of that. So it will be like the number of people having height 150 upon total number of people in the world. So this is actually a continuous distribution over here, because the random variable is continuous. In this case the random variable is discrete, hence the distribution also, probability distribution is also like called discrete distribution. So there are two types of probability distributions, continuous distribution and discrete distribution. Now we are going to the discussion part of that distribution. So let me share the screen quickly.
Sir, it was a bell curve, na? It is known as a
Yeah, we'll come to that. So in general, like many of the data in real world, they follow this distribution called normal distribution or Gaussian distribution or bell curve. So
what does the peak denotes in this curve, sir?
peak
The
denotes it is the most probable event that can occur.
in terms of height, what does it will denote?
That will denote the maximum, like the probability of particular height occurring. What is the probability of a person or people in the world having height equal to say 140 centimeter? So every point will show you the likelihood of that particular height or the probability of that particular height.
Okay.
Yeah. So yeah, random variable we have seen. So because of depending on the nature of this random variable, we can have either discrete distributions or continuous distribution, but the shape of these distributions vary, and there are multiple such kind of distributions which like represent the probability values. So we'll discuss this in detail. Like we have binomial distribution, Poisson distribution, and hypergeometric distribution, which are discrete in nature, and we have uniform, exponential, and normal. The normal one which we just saw, these are all continuous distribution because the random variable is continuous in nature. Okay. So yeah, I was supposed to discuss all these things, but yeah, let me so I have given just an overview of what a distribution is. We will probably discuss the different types of distributions in the next class. Let me just show you like what these distributions are. So binomial distribution, it again needs like concepts of permutations and combinations. So the binomial distribution is given like this. So out of n, I have say n trials, and then out of that I am taking x trials which are in which I am having success. For example, I have a set of balls, say red ball, green ball, blue ball, and probability of occurrence of red ball is what say I have 3 red balls, 3 blue balls, and 3 green balls. So what is the probability of getting a red ball?
1/9.
1/3.
It will be 1/3 because it will be 3/9, right? There are 3 red balls, so it will be 3/9.
3/9, sir. 1/3.
Yeah. Okay. Okay. Please wait for a minute. My laptop's battery is getting discharged. Sorry for that. Let me share my iPad screen. Is it visible?
Yes, sir.
Yeah.
Yes,
Say
sir.
I have 3 red balls,
Yes.
2 blue balls. Okay, let us change the count, and 4 green balls. So what is the probability of getting a red ball?
3/9.
9.
3/9. Okay. Probability of, okay, so now I say that getting a red ball is success and getting any other ball is a failure. So probability of getting non-red ball will be
2/3.
non-red ball.
6/9.
6/9. 2/3.
6/9, which is nothing
2
but,
by
sorry
3.
everyone,
2 by 3.
please be on mute. Yeah, so it will be 6/9, which is nothing but 1 minus 3/9, or 1 minus probability of red. So this can also be written as R bar or R complement. So getting an R red ball is an event, and this is my sample space. So this will be like complement of that event. So whatever is the probability of R, the probability of the complement of R will be 1 minus probability of R. Is it clear? Because the probability of this entire thing will be 9 over 9, which is 1. Maximum probability is 1. So I am taking only this element. Yeah. Okay, so probability of R complement will be 1 minus probability of R. So I am saying this is my success, which is denoted by P, and this is denoted by 1 minus P or Q. I hope this is clear till now.
Yes, sir. Sir, I have a doubt. Sir, could you say the website which is available to to do the NPTEL questions?
NPTEL questions. Oh, you have not visited Swayam portal till now?
I have visited, sir. I have to practice, sir. I'm asking which website can we
Oh, for
visit.
practice part, there is no specific website actually. You can go to YouTube, and then whatever concepts you are having doubt in, you can look into that topic on YouTube or any other online sources you prefer.
Okay, sir. Thank you, sir.
But I think you were sharing for some probability based, no?
Yeah. For probability, if you have any queries in probability, you can simply search that topic over here. Like say problems in probability, problems on probability.
Problems on probability.
Yeah, you can search whatever query you have, and then you'll get multiple such sources in which you can look into. Okay.
Sir, if somebody has missed the deadline for submitting the assignment, uh, what is the remedy for that?
No, Saurabh, I don't think so. It will. There is any remedy for that. If you have missed the deadline, then it's gone. Yeah, they have very strict. NPTEL has very strict deadlines.
Okay, sir.
Yeah.
And the submission of all the assignments is necessary in order to take the exam, right?
Not sure, but yeah, you will have to like submission. It will be counted towards your final grade, I think. But I think you, irrespective of that, you can take the exam. But yeah, be to get a good grade, I think you need to submit all the assignments.
Okay, sir.
Sir, I have a doubt. Week zero assignment also we have to be submitted.
Not very sure, Shravya. Like you can ask these logistics related queries on the discussion forum, because I am not a regular team member of NPTEL. So yeah, I'm not very sure about it.
Okay, sir.
Yeah. Okay. So this is probability of success and probability of failure. Okay. Now my question is, like, out of this, so I am doing some trial. The trial is like taking 3 balls. So what is the probability of getting one red ball? Like, so how will I explain that in just a second? I am having some n trials. Out of those n trials, in R trials, I am getting success. So, as we saw, like if I am getting success, say I am having this n trials. In each of the trial, I can either have success or failure, right? Is it clear?
Yeah.
Yeah. So I have n such trials.
This.
I have n such trials, and in each trial, I can have a success or failure. I can have red ball or some other ball from say it's replacement, like it is with replacement, like I'm taking a ball and it is a red ball, so that is like my success, and if it is some other color ball, that is failure. So I'm keeping that particular ball back into the bag. So for every trial I can have success or failure. So out of this n trials, I am getting success in some r trials. So is this particular thing clear to everyone? In the r trial, in the n trials I'm getting r successes, so the probability will be p into p into p into p r times, and the rest will be failures. So the total probability of getting r successes in the n trial will be NCR into p to the power r 1 minus p to the power n minus r. So I am having r successes and n minus r failures.
Sir, can you please explain this with an example? It will be clear after that.
So the example is this only, Saurabh, that you are taking r ball, you are selecting a ball in this first trial. Trial is nothing but you are doing some experiment of selecting a ball. So you are taking, say you got a red ball in this, so this is success. You got green ball in this is failure, or non, I should write non red ball, red ball, red ball, and non red ball, and so on. So my success, say let's say I want 3 success in this n trials or 7 trials, n equal to 7. So out of these 7 trials, I am having red in 3 of the cases and non-red in other cases. Till now, is it clear?
Yes, sir.
Yeah. Now, but my 3 successes can be anywhere. It can be like this, others are non-red, or like this, and others are non-red.
You are restricting the 3, you are taking just example, or restricting your success to 3 only?
Restricting the success to 3. There are 7 such trials, and
Yeah,
out of which we are getting 3 successes.
maybe more also.
No, the exact 3 successes.
Okay.
Yeah. So out of 7 trials, you have 3 positions in which you can get successes. Okay. And then the probability of this event will be getting R, 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 and non-R, non-R, non-R. It will be P into P into P into 1 minus P into 1 minus P, and so on. These are all independent. So we saw that if 2 events are independent, so their probability is the multiplication of the probability of individual events. So in this case, there are 7 such trials, and in each trial you are getting either failure or success. So probability of success is P, probability of failure is 1 minus P. So in this particular instance, you are having this P, 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 and then 1 minus P, 1 minus P, 1 minus P. In this particular part, you will be having 1 minus P into P into P into P into 1 minus P, and so on. In the first one, you will be having P into 1 minus P, and so on. So P is occurring how many times? 3 times. And 1 minus P is occurring how many times? 7 minus 3 times, right? In any of these experiments, arrangements. Is it clear? What about others? Please let me know, like if it is not clear, I'll explain it again.
Yes, sir, it's clear.
Okay, so to the total number of arrangement I can have with 3 successes in 7 places is 7C3, and it will be p to the power 3, like having the 3 success, and 1 minus p to the power 7 minus 3, having 7 minus 3 failures. So in general, it is in n trials you have r successes and the probability of success is p, and probability of failure is 1 minus p. So this particular distribution where a random variable is the number of successes is known as, this distribution is known as binomial distribution. Okay,
In this case, n is the number of trials.
n is the number
R-
of trials and r is the
R
number
is
of successes.
okay. P
P is the probability of getting the success. In our case, it was probability of getting red. Probability of getting red was P, and probability of getting any other color was 1 minus P or Q. Is it clear? Sorry.
Yeah, now it is clear, I think.
Yeah, but please, yeah, I understand that it will be like too many concepts in one class. So yeah, please go back, look into the details. Like there are multiple videos. Again, in the same channel, I think the JB statistics. You can go, and there are, I think, certain videos on that channel itself, or maybe you can look into like binomial distribution, and there will be a number of videos available on YouTube which will be explaining binomial distribution from scratch. Let me just show you quickly. So if you just search binomial distribution, see there is this video by 3 Blue 1 Brown which will intuitively explain you what binomial distribution is. There are other videos as well, an introduction to binomial distribution and so on. So there are n number of videos over here which you can look into and get your, if you are not getting in it cleared in a certain video, you can definitely look into another video. So this is JB statistics video which is on introduction to binomial distribution. So you will kind of like also get visuals over here, like so the person will like try to visually explain
gives us no information
with an example like how binomial distribution is forming. So please look into all these resources. It's very difficult to cover all this in 2-hour session every week. Looking at the syllabus that is supposed to be clear, like covered. So I would urge everyone to spend more time outside of these sessions and the videos that you watch on SOAM portal. You spend some time to understand the basics, because if these basics are not clear, then it will be difficult to understand the later concepts. For example, we are going to discuss in this week, I hope my screen is visible. Okay.
Yes.
Yeah, so we are going to discuss Poisson distribution, hypergeometric distribution, uniform exponential. So all these things need like the basics of probability to be clear, and also like some random variable, like basics of random variable, the concept of random variable. Entire thing is dependent on that. So if you are not very thorough with these concepts, please look into multiple resources and get those cleared. Like practice more and more problems on probability. You can find the problems on YouTube as well. So if you just simply search problems, practice problems on probability, so you will also find out like there are tutorials which are discussing certain problems on probability, like how to solve certain problems. So
Are there any videos that are in Hindi language also?
you can search it in Hindi also, like for example practice questions of probability in Hindi, so you might get questions in Hindi as well, means the practice videos on tutorials on in Hindi.
Yeah, because if we get in Hindi, so the basics will be cleared first of all.
Yeah, in any language, like whatever language you are comfortable with, there might be video. I'm not sure like if it is there in all the languages, but yeah, there might be some people who are creating all these videos. For example, this probability with cards. So yeah, you can look into the videos on YouTube. It may or may not be in your mother tongue, but yeah, definitely there will be videos in English. Okay, so please do look into it. Yeah, and one more thing, there might be people who might be suggesting you to use ChatGPT and other AI chatbots. I don't recommend it generally because ChatGPT might give you incorrect answers sometimes. It is not that reliable. So you may use it as an aid, but don't rely on it because it might also give, it is a generative model, it generates answers. So don't rely on ChatGPT. Please get the concepts cleared from authentic sources like books or the video tutorials available on YouTube. So that is highly recommended. And after that we have to discuss all this sampling theory and sampling concepts, and then go on to distributions of sample means and all. So to have all this, you need to have basic grasp on the probability concepts. So please go to all these sources, get your concepts clear, and then we'll move ahead, because it will just create confusion if I cover the other concepts like distribution of sample mean, proportion, and the point estimate and confidence interval. So
By the way,
yeah.
do you have any books in PDF form?
No, I don't have, sir. So but you can definitely look into online sources, like there are multiple sources on which in which you can get, from which you can get the PDF copies of.
Okay.
Yeah, yeah.
These PPTs and the video will be uploaded today only or
Yeah, by
tomorrow,
tonight, I'll be uploading these videos.
along with the all the PPTs,
Yeah,
the
yeah,
question.
question I'll be uploading week 2 and week 3 slides. You can look into the slides earlier itself, like I have other questions in this, and we can discuss it in the next class.
Yeah,
That will save
there
some time.
are there slides related to the topics also,
Yeah, yeah,
like
yeah.
vision and binomial, other slides explaining these topics.
Slides won't explain these topics, but there are questions on these topics. But if you want explanation, you can definitely look into the videos by Professor Ramesh. If those are also not sufficient, like if you are not able to grasp the concepts there, please feel free to look into other resources on YouTube, means other videos on YouTube.
Okay, sir.
Yeah, yeah. The important part is to get your concepts clear. It doesn't matter from which source you are like getting those things clear, but use authentic sources only. Like don't go for Chat GPT to make you understand, like help you in understanding the concepts.
In YouTube also there is so many things which may not be authenticated.
Yeah, but there are, so you can always look into the number of views a particular video is getting, for example.
Okay.
So if you just search this, it will, there is this filter and it will only show you the relevant videos. So
Okay.
yeah, you can see the count of the view count over here, 138K and so on. So these are
Okay.
actually authenticate sources which many people have referred to. So you can definitely look into those.
Fine.
Yeah, yeah. Yeah, so let me quickly tell you, like distribution we'll discuss in the next class, next session, but I want to discuss about sampling. So in statistics, okay, let me, okay, why do we need sampling? Like does anyone know what is the use of sampling?
Sir, in order to get the result of a large
Sorry, Saurabh, your voice is bit noisy. There is a lot of noise in the background. Okay, can
Just to arrive some conclusion or projecting something.
okay. So see, in the second session we saw this statistics like mean, mode, median, and all, right? So you want to find the average height of people in this world. But is it possible to measure the height of each and every person or get the data from each and every person in the world? The answer is no. So to infer what can be the average height of people in the world, you have to get a subset of people. So the entire set of people in the world is your population, and the subset that you are getting, that is sample. Now how do you get this sample? So the way of getting these samples are different, that's what we are going to discuss now. Say you have 1 lakh milk bottles and you want to measure the average amount of milk in each bottle. So you cannot go and then measure individual bottle, like the quantity of milk in individual bottle. So you can just take some 50 bottles at random and then measure the quantity of milk in that, take the average, and then you infer that okay, this 1 lakh bottles might be having so and so amount of milk based on the sample that I am having. So this is the way in which this sampling is done is important. So there are different kinds of sampling. So first of all, getting the mean, standard deviation and all, this kind of statistics is known as descriptive statistics, where you have the entire data with you, like the population data. But if you don't have the population data, or it is not feasible to study the entire population, you take a sample and then infer the parameters of the population. Like the mean of the population might be this, the mean quantity of milk in all the 1 lakh bottles might be so and so based on the sample you are taking. So that is known as inferential statistics. So you are inferring something about the population based on the sample statistics you are having, like based on the statistics you are computing on the sample. So the way in which sampling is done, so the types of sampling, it can be done in a random way. I can randomly select any milk bottle, any 50 milk bottles out of those 1 lakh bottles. So that is like in a random way. But in that also we have certain subtypes, we will discuss that. And it can be non-random. Say I take only the first 50 bottles that were filled by the machine. So I'm not having any randomness over there. I'm taking only the first 50 bottles that were filled. I'm not considering the rest. So that is like a non-random sample. So in random sample, if it is a simple random sample, generally we prefer random sample so that we get varieties of data points, because in non-random sampling you are biased towards something. Say okay, we will discuss non-random sample in detail. So in random sample we have 4 subtypes. Simple random sample is randomly taking any of the 50 bottles out of those 1 lakh bottles. So you generate some random number and take those random bottles from the 1 lakh bottles. Another is stratified. So what you do, you divide the population into multiple groups, and each group is having, forget about the bottles now, each group is having a homogeneous set of samples or like data points. So in that case, what you do, you have this groups, each of the group is known as stratum. So from each stratum you take some sample, from the other stratum you take sample, from third stratum you take some random sample, and then so on. So you ensure that there is some random sample from each of the groups. So for that you use this stratified random sampling. We'll discuss questions on this. Then there is systematic random sampling. So what you do, you take every nth element. So you divide the population into k parts, and from each of the part you take the nth, you say third bottle, milk bottle. So I have 1 lakh bottles. I am dividing the 1 lakh bottles into say 1000 groups, and from each of the group I take the third bottle. So that also is like taking nth sample from each of the group is systematic sampling. You are doing it in a systematic way. And then cluster sampling, again forget about the bottles. In a general scenario you kind of try to cluster certain groups or certain data points, and then from each cluster you take sample. That is another way. So this was all about random sampling. We'll discuss this in detail. I am just giving you an overview because I have to end the session now. But
So can you please repeat stratified?
yeah,
I'm unable to understand it.
I will have a question on stratified random sampling. So yeah, let me come back to that. And non-random sampling is we have convenience non-random sampling, in which you sample based on the convenience of the user. So as I cannot go to every country in this world to measure the height of people, I can simply go to my city and then measure the height, or just to the building in which I am living and go and measure the heights of those people. So that is as per my convenience. So that is convenience sampling, the convenience of the person who is doing the sampling. And then second is judgment sampling. So you know that you can get, so see, if you are measuring some data from some people and you know that so and so people are like normal, like they are not having any disease or so. So you are having a basic judgment that these are the set of people who are not having any diseases, so I have to collect some medical data from them. So you are having a judgment, prior judgment, that I'll get a better data from so and so people. So in that case sampling is called as judgment non-random sampling. Quota sampling is actually you are having a quota for each of the categories. Say in parliament you have like certain number of males and certain number of females. So you have quota for males and females. So you take some females from the female quota and take some males from the male quota. So that is known as quota sampling. Again it is like your quota is there, so it is biased in nature. It's not random, like quota is already there for females and quota is already there for males. From that you are selecting female and males. Then snowball sampling is based on the judgment or the feedback from the current members. Say you are collecting data from 10 people, all are normal, and those 10 people also know that who are the other people who might be normal in the sense like not having any health conditions as such. So they may refer to some other people who might not be having any health conditions. So that is the snowball way of sampling, in which you are taking the feedback from the current users or the subjects and then getting samples, more and more samples. So these are different types of samples. And let us have some questions and then we'll end the session. It's going beyond 2 hours every time, but yeah, I can't help it actually. Like I try to restrict it to 2 hours, but it goes beyond that. Still we are not we have not discussed the distributions and sample means.
So can you please repeat stratified?
Yeah, stratified. So I'm coming to that. The first question itself. Okay, so what kind of sampling are we doing over here? So we have these groups.
Stratified.
So this is a stratified sampling. Okay, I'm just quickly discussing this. So this is stratified sampling. So you have homogeneous groups. Each group is called as stratum, and from each stratum you are taking certain number of samples. So from first stratum I am taking 2 samples, so 1 and from second I am taking 2 samples, 2 2 and so on. So this is known as stratified sampling. So you divide the group into different strata. entire population, and then from each stratum you take samples.
Just 1 minute. How this homogeneity of the sample can be assured?
That depends on the kind of data you are dealing with. If it is like students in certain age group, so 5 to 10 years will be in one group, 10 to 15 years will be in one group, 15 to 20 will be in one group, and then from each group you are taking two students.
Okay.
Yeah. So that is the stratified way of sampling. Okay, a population is a set of all items or individuals of interest. Is it true or false? Please answer quickly. Everyone?
True.
Yeah, it's true. A population is a set of all items or individual of interest. Say height of people. So all the people are being considered in the population. The specific value of random variable. Okay, I'll skip this particular question because we have not discussed estimator. Okay, what is the kind of sampling being done over here in this case?
Systematic.
Okay, somebody has already answered. So it's systematic because you are taking every third element in each of the group. So all the groups are same. It's not like homogeneous group here, homogeneous group here, and so on. Irrespective of this, you are dividing into equal parts, and from each part you are taking the nth sample.
The third element, right?
Yeah, in this case it's third element. So that's the way the sampling is being done. So this is systematic sampling. So you divide it into equal parts, and from each part you take the nth sample.
So what's the difference between stratified and systematic, sir?
So in stratified case, you are ensuring that every part is homogeneous in nature, but in this case it is not.
Sir, one small doubt.
Mhm.
Okay. So can I ask, sir?
Yeah, please.
Uh, Sir, will it come?
Yeah, you can ask
Sir, will it come? Assignment questions will come?
this kind of questions. If you are you asking if this kind of questions will be coming in exams?
Yes, sir.
Yeah. So you might expect some MCQ questions. So these questions I have designed to help you with, like, help you understand the concepts. The questions that you might be getting will be like very similar to the questions that are in your assignments, and some of these questions were asked in the previous offering of this course. So these questions also, some questions were also taken from the previous assignments, like this course was offered last time also in 2 semesters back. So I have taken some questions from there as well.
Sir, I'm asking exam will, in this question will come in the exam, 75 marks question.
I'm not very sure about the sorry, who. So yeah, please verify the kind of questions you might expect. It will be mostly the way. It will be mostly like the way they are in the assignments. There won't be uh, any different sort of questions apart from those.
Okay, sir.
Yeah.
So, sir, how can we attempt the assignment before studying the material?
Yeah, you'll have to study, and then that's what I'm trying to say, that you don't have to be dependent on the course material that is shared on NPTEL and these live sessions. Yeah, live sessions are there, you can get your doubts clarified, but if the doubts are not getting clarified in these sessions, you can definitely refer to other resources online and then attempt the assignments.
Yeah, because we cannot rely on Chat GPT every time. They
ChatGPT,
wrong.
I will never recommend anyone use ChatGPT blindly. If you know the concept, have any background of the concept, and you want to verify something, then in that case only use ChatGPT. Else, no. It's not a like a right way to use that. So I would recommend you go to the authentic sources online and then get your doubts clarified. If you have any particular query, you can ask during the live sessions. Okay. So I think after that all these questions are based on probability distributions. So we will discuss this in the next session, because it's getting like too elongated, because I have to discuss the Python part of it also. Like there is all these Python notebooks are there. I won't share it now, or maybe I'll just keep it in the drive folder. If you have time, you can look into this, just to save your time, like for those who may not be having like 2 hour of time. So you can just at your own leisure, you can go and look into these notebooks and then run them and then try to get these concepts clear. If you do not understand anything, you can, we will anyway be discussing this in the next session. So I'll clarify all these queries, whatever you may have. Okay. So yeah, that's what we had all about today in today's class. So if you have any further queries, please feel free to ask in the next session. Yeah, thank you so
Thank
much.
you, sir.
Thank you so much everyone for attending
Thank
the
you,
class.
sir.
Yeah, and sorry if I was not able to clarify any of the queries. Yeah, 2 hours are really like pretty short for explaining all these things. So please go back, look into the material online, and ask me any specific, like please cover up the basics first, and then we can discuss other concepts like distributions and other advanced concepts later. So I don't want to spend more time on covering very basic things. So I would recommend, like, yeah, go to online sources and get those cleared. Get the complete syllabus for the final examination. Manik, I think the syllabus is fixed, and the YouTube, like the videos for this particular course are available on YouTube. So if you just search data analytics with Python, in Python, sorry, okay, with Python, so you will get all these videos here. The videos are available for later weeks as well. So the assignments are released every week, but the material is already available on YouTube. So you can check the topics which are there over here, like hypothesis testing. Then it will be like different types of statistical tests will be there, and then there is linear regression and multiple regression and so on. So all these concepts are here. You can get the syllabus from here. Let me just share the link in the chat itself. Yeah, so yeah, please again look into the online sources, get your basic concepts clear, so that we can focus on the topics that are relevant to this course, like the advanced topics, sorry. Okay, so thank you everyone for joining. If two NPTEL courses have exams on the same date and we pay exam fee, I'm not very sure, Janani. You will have to contact the course coordinator or the NPTEL team for that. I'm not sure if you can take two courses on the same day. Like if they are in different slots, like one is in the morning and one is in the evening, then fine. But you need to ensure that they are not clashing, like the slots are not clashing for two exams. Okay, yeah, please confirm with the NPTEL team.
Yes, sir, sure.
Okay, thank you everyone for joining, and I hope you learned something from this session. So see you all in the next session. Thank you.
Thank you.